In this class, we shall discuss some problems on general formalism of quantum mechanics. Problem number 1. A and B are two operators defined by A psi of x equal to psi of x plus x and B psi of x equals d psi of x by dx plus 2 psi of x, and we are going to check whether A and B are linear operators or not. And of course we know that in quantum mechanics all the operators are linear operators. In fact, the Schrödinger equation itself is a linear equation. The solution of Schrödinger equation is nothing but linear solutions. And suppose if there are more solutions, then we'll have to go with linear combination of solutions. So wherever we look into the solutions or the equations or operators, everything will be linear in quantum mechanics. The definition for linear operator is given by O operator operates on psi 1 and psi 2, which is equal to operator operates on psi 1 plus operator operates on psi 2. That is, the operator operates on the combined system is equal to operator operating on the individual system. So this is additive property, the first property. If we consider as a linear operator, it must satisfy the additive property, the first one. And second one is scalar multiplication property. That is, the operator operates on C is a scalar, and the function psi is a function, which is equal to C the operator operates on the function. So the second one is scalar multiplication and the former one is additive property, and it has to satisfy these two conditions. Only then we can say that the operator is a linear operator. But according to the problem, we are going to take only the first one. That is, the operator operates on the combined system will give us the operator operates on the individual system. So now there are two subdivisions, and we are going to find out A and B whether they are linear operators or not. First we will go with the first section, so which goes like this: A psi of x, which is equal to psi of x plus x. So A psi of x means A psi 1 plus psi 2. So this is your left hand side, and right hand side will be psi 1 plus psi 2 plus x. Of course, psi of x we have taken into psi 1 plus psi 2 plus x. Now just take left hand side. Left hand side is of course A psi 1 plus psi 2, which is equal to, use the additive property, that will give us A psi 1 plus A psi 2. What is the right hand side? Right hand side goes with psi 1 plus psi 2 plus x, which is not equal. Both are not equal. So A operator is not a linear operator. We will go for the second division. That is B psi of x, which is equal to d psi of x by dx plus 2 psi of x. And of course use the additive property B for B psi of x, which is equal to B psi 1 plus psi 2. So right hand side, that will so left hand side will be B psi 1 plus B psi 2. What is the right hand side? We will go with right hand side, which is given as d psi 1 of x divided by dx, and of course psi 1 plus psi 2. So d psi 2 of x divided by dx plus 2 psi 1 of x plus 2 psi 2 of x. So here B psi 1, which is equal to the first term and third term, B psi 2, which is equal to the second term and fourth term. So look at the terms. So exactly they are equal. That is, B psi 1 equal the addition of first term and third term, and B psi 2 is the addition of second term and fourth term. So left hand side is equal to right hand side. So we can say that B operator is the linear operator. And of course in quantum mechanics we always deal only with the linear operators. So operators must be linear. Linear in the sense we can say that, suppose if there are 3 chairs, I am asking only one student to occupy any one of the chairs. So one student will occupy any one of the chairs. Of course we know. Suppose any small particle, say for example electron. Suppose if I ask the electron to occupy any one of the chairs, then electron is associated with a wave. So electron cannot occupy one chair, whereas it's a combination of all the three chairs it will occupy. That is, the electron is associated with the wave, so it will occupy the linear combination of all the three chairs. But the moment when you are going to measure, if I am going to measure the electron, immediately there will be a transformation from one chair to another chair. This transformation is nothing but a linear transformation. Okay, so this is the idea about linear. Now we'll go with problem 2. Check if A and B are Hermitian operators. So A matrix is given, B matrix is given. We are going to check whether A and B are Hermitian matrices or not. So A matrix is 0, 0, I row wise. So 0, 1, 0 minus I 0, 0. So for the Hermitian, just take the complex conjugate. So taking the complex conjugate of A will give you 0, 0 minus I 0, 1, 0 I 0, 0. That is, wherever you find I, you just substitute minus I. Wherever you find minus I, substitute I. That's all. Now the next idea is just take the dagger. Dagger means just change the rows into columns into rows. So A star, already we have taken the complex conjugate of A, which is given as this one, and which is given as this one, and change the rows into column into rows. So 0, 0 minus I will become 0, 0 minus I. The first row will become first column. Similarly, second row will become second column, and third row will become third column. So you just look at the first matrix and the last matrix. So we have given three matrices are here. You just compare the matrix A and A star dagger. Both are equal. So we can say that A is a Hermitian matrix. Now we'll go for B. B matrix is given as in row wise 2y0, 3, 1, 5, 0 minus I minus 2. Your B star will be, just take the complex conjugate of matrix. That will give you 2 minus I 0, 3, 1, 5, 0 I minus 2. Now take the dagger, that is rows into column into rows. So that will give you 2, 3, 0 minus I 1 I 0, 5 minus 2. You compare the first matrix and third matrix, that is B with B star dagger. So they are not equal. So we can say that B is not the Hermitian matrix. Okay. Now we'll go for the problem 3. Show that the linear momentum operator is Hermitian. And of course we always deal with the operators in quantum mechanics. They are all Hermitian matrix, Hermitian operators. Only then we can get the real values. See, all the operators which are there in quantum mechanics will be Hermitian. Okay. So now we will go for linear momentum. Linear momentum is given by Px, which is equal to minus I h cross d by dx, partial d by dx. And of course the expectation value of Px is given as Px sandwiched between your normal ordinary wave function and its complex conjugate, which is given as minus into plus infinity psi star Px psi dx. You just substitute Px, which is equal to minus I h cross partial d by dx. Now we are going to solve this integration using udv method. Integration udv equals uv minus v du, that we know already. So here u is given as psi star and dv is taken as minus I h cross d psi by dx. Okay. Your u will be psi star and dv is considered as minus I h cross partial d psi by dx. Now of course u equals psi star, so du equals d psi star. dv equals minus I h cross d psi by dx. Just take the integrating on both sides, that will give you v. The v equals minus I h cross psi. Integrate on both sides will give you v. So now we can find out the values of u and v. Now we know already u dv equals uv minus v du. You substitute the expressions for u and v. We will get u equals psi star, v equals minus I h cross psi. So we will get minus I h cross psi star psi with the limits minus into plus infinity, and you will go for the second term, which is nothing but minus v du. So minus integration of v du. V equals minus I h cross psi, and your du equals d psi star by dx. Okay, and of course your psi star psi with the minus into plus infinity. The very important property for any wave function, it has to die out at infinity. Correct? Whether it is plus infinity or minus infinity, it has to die out. So the uv, that term will go off. It will become 0, and we'll go for the second term. Minus into minus plus, you have I h cross psi d psi star by dx. You just take psi this side, I h cross d psi by partial d by dx, psi star this side, and you will have this term. You look at the term which is in the bracket, which is given as px star. Already we know that px equals minus I h cross d by dx. So px star will be I h cross d by dx. So it clearly implies that px equals px star. Okay, your px star is given by plus I h cross d by dx, whereas px is equal to minus I h cross d by dx. So one is the complex conjugate of another one. So the expectation value of momentum is equal to its complex conjugate, hence it's real. So linear momentum operator is real. Now we'll go for the problem 4. Problem 4 is given as your ket psi 1 equals, in terms of column, 1, 2, 3i. Ket psi 2 equals 1, 1, 2. We are going to find out the inner and outer product of psi 1 and psi 2. So given that ket psi 1 equals 1, 1, 1, 2, 3i, ket psi 2 equals 1, 1, 2. So just take bra psi 1. Just take the column vector into row vector will give you bra psi 1. So bra psi 1 equals 1, 2 minus 3i. You will have to take the complex conjugate also. Take the complex conjugate first and take column into rows. So that will give you bra psi 1. So bra psi 1 equals 1, 2 minus 3i. Similarly, bra psi 2 will give you row wise. Okay, 1, 1, 1, 2. Because there is no I here, so we can write 1, 1, 2. Now we just find out the inner product of psi 1 and psi 2. That is bra psi 1 and ket psi 2, which is equal to, you substitute for bra psi 1, which is given as 1, 2 minus 3i, and your ket psi 2 will be 1, 1, 2. So using matrix multiplication, that will give you 3 minus 6i. Now we'll go for bra psi 2 with the ket psi 1, inner product of psi 2 and psi 1. That will give you 1, 1, 2, 1, 2, 3i. Just take the matrix operation, that will give you 3 plus 6i. You just compare these two, psi 1 with psi 2 and psi 2 with psi 1. One we have got 3 minus 6i. The another value that we have obtained as 3 plus 6i. So one is the complex conjugate of another one. So looking at the results, it implies that psi 1, psi 2 star will be psi 2, psi 1. So one is the complex conjugate of another one. Now we will go for outer product of psi 1 and psi 2. And of course, you have ket psi 2 with bra psi 1. That will be 1, 1, 2, 1, 2 minus 3i. Use the matrix operation. You will get 1, 2 minus 3i, 2, 2 minus 3i, 2, 4 minus 6i. So the matrix of, so the outer product will give you matrix, whereas the inner product will give you number. Okay, it's very important conclusion. Now we'll go for problem 5. If A equals 17, it's 2 by 2 matrix, 17 minus 35, 6 minus 12, and your ket psi is phi 2, find A psi, which is equal to lambda psi. We are going to find out whether this matrix is satisfied with the relation A psi equals lambda psi r naught. So your A psi is given as 17 minus 35, 6 minus 12, 5 2. That operation will be 17 minus multiplied by 5 will give you 85. So then minus 35 multiplied by 2 will give you 70. So minus is there. So 85 minus 70. And then next one will be 6 multiplied by 5, 30. Minus 12 multiplied by 2, that will be minus 24. So 30 minus 24. 85 minus 70 will give you 15. 30 minus 24 will give you 6. So 2 by 2 matrix. 17 minus 35, 6 minus 12 with operation 5, 2. The answer that we have obtained was 15, 6. 15, 6 column is converted as 3, 5 by 2. You look over left hand side, it is 5 by 2. And right hand also we have 5 by 2. So it is eigenvector. Okay, it's eigenvector. 5 by 2 is eigenvector. We can say ket psi. Eigen ket psi. So your lambda will be 3. A matrix is there, 2 by 2 matrix, which is the same one, and your ket psi will be 5 by 2, 5 2, and your lambda will be 3. Again your ket psi will be 5 2. Okay, so we can say this is eigenket. So it has satisfied A psi, which is equal to lambda psi, and lambda we obtained as the value as 3. Now we'll go for the last problem, problem number 6. Consider the states. Our ket psi equals 9i51 plus 252, and ket chi, which is equal to minus I by root 2, ket phi 1 plus 1 by root 2 ket phi 2. And here phi 1 and phi 2 they form a complete and orthonormal basis. So they are orthogonal. Okay, and of course they are complete. Now the first division is we are going to calculate the operators ket psi bra chi and ket chi bra psi. Whether they are equal or not, we are going to find out. And given that ket psi equals 9i51 plus 252, and we can have bra psi immediately. Just take the complex conjugate of this. And of course when you are going to have the matrix, it must be the earlier one should be column matrix and the next one should be row matrix. We know already. So now just take the complex conjugate. Complex conjugate, that will give you minus I bra phi 1 plus 2 bra phi 2, and your ket chi equals minus I by root 2 phi 1 plus 1 by root 2 phi 2, and just take the complex conjugate of it, that will give you bra chi, so which is equal to I by root 2 phi 1 plus 1 by root 2 phi 2. So first we will calculate this, that is ket chi and bra, ket psi and bra chi. Ket psi has been given as 9i phi 1 plus 2 phi 2 multiplied by, and your bra chi will be I by root 2 phi 1 plus 1 by root 2. So we will calculate. We are going to multiply now. So first term, here there are 2 terms this side and 2 terms in the bracket. Now first we will take the first term multiplied by the first term of the second part, and first term multiplied by the second term of the second part. Okay, so 9i phi 1 multiplied by I by root 2 phi 1, that will give you I into I squared minus 1, so minus 9 by root 2. You have this phi 1 and this phi 1, that is ket phi 1 and bra phi 1. The first term is over. Similarly, first term in the first part multiplied by the second term in the second part, so which is equal to 9i by root 2. You have ket phi 1 and bra phi 2. Similarly, second term in the first part multiplied by the first term in the second part, so that will give you plus 2i by root 2 ket phi 2 bra phi 1, and the second term in the first part multiplied by the second term in the second part, that will give you plus 2 by root 2 ket phi 2 bra phi 2. Okay, so now we will go for the second one, that is ket chi and bra psi, so which is equal to similar operation we are going to have. So this will be the first part and this will be your second part. We are going to multiply. So as we discussed earlier, you just multiply this and this term will give you minus 9 by root 2. I into I squared minus 1, already minus minus plus. So you will have minus 9 by root 2, 5 1, 5 1. Similarly, go for the second term. So that will give you minus 2i by root 2, ket 5 1, bra 5 2. Minus 9i by root 2, ket 5 2, bra 5 1, plus 2 by root 2, ket 5 2, bra 5 2. Now you just compare these two. It implies that ket psi bra chi, it is not equal to ket chi bra psi. So both the answers are not equal. So we can say that they are not equal. Okay. Of course, first term is equal. The last term also equal. And second term and third term they are not equal. So look at the second and third terms, they are opposites in sign. So they are not equal. Calculate the trace of a matrix. Usually trace of a matrix is the addition of diagonal elements, we know already. So now we are going to calculate the trace of ket psi and bra chi and trace of ket chi bra psi. So we know that the trace of ket chi bra psi, which is equal to trace of ket chi bra psi, which is equal to the inner product of chi and psi. We know already that trace of AB equals trace of BA. So using this condition, we have written this term. Now, so we know that bra chi is given as I by root 2, phi 1 plus 1 by root 2, phi 2. And we know that ket psi is given as this according to the problem. So we will calculate now inner product of chi and psi. So which is given as the first term, first part and the second part, multiplication. That is I by root 2, phi 1 plus 1 by root 2, phi 2 multiplied by 9i phi 1 plus 2 phi 2. But here we are talking about only the trace of a matrix. Trace of a matrix, just now we discussed that it is the addition of diagonal elements. So we don't bother about the half diagonal elements. That is phi 2 and phi 1. We will bother only phi 1 and phi 1, phi 2 and phi 2. We will never bother about phi 1, phi 2 or phi 2, phi 1. So we are going to leave the rest of the terms. We are going to have only phi 1 with the phi 1 or phi 2 with phi 2. So that will give you answer as minus 9 by root 2 phi 1 phi 1 plus 2 by root 2 phi 2 phi 2. And of course phi 1 will give you 1 and phi 2 also will give us 1. So we will get minus 9 by root 2 plus 2 by root 2, which is equal to minus 1 by root 2. Now we will go for the trace of ket chi and bra psi. So which is equal to use this one, trace of AB equals trace of BA. We will have trace of ket psi and bra chi, which is equal to bra psi ket chi. And of course bra psi is given as this one and your ket psi is given as this one. So we are going to find out the inner product bra psi and ket chi. So which is equal to this part multiplied by this part. As we discussed just now, that only the terms phi 1 and phi 2 will play a role, and similarly phi 2 and phi 2 will play a role, not phi 1 and phi 2 or phi 2 phi 1, because we are talking about only the trace of a matrix. So accordingly we will get minus 9 by root 2 plus 2 by root 2, which is equal to minus 7 by root 2. So we can say that trace of AB equals trace of BA. So now the last one is calculate the trace of ket psi and bra psi. Similarly, trace of ket chi bra chi. So now similar terms we are going to have. So bra psi is given as minus 9i phi 1 plus 2 phi 2 and ket psi is given as 9i phi 1 plus 2 phi 2. You just find out trace of ket psi and bra psi, which is equal to the inner product of psi and psi. So the first part multiplied by the second part. So 9i phi 1 plus 2 phi 2 multiplied by minus 9i phi 1 plus 2 phi 2. So that will give you minus 9 9s are, that will give you 81. I into I squared minus 1, already 1 minus is there, so it become plus, so you will have 81 plus 2 to 4, so 81 plus 4, that will give you 85. Now we will go for bra chi, which is equal to I by root 2 phi 1 plus 1 by root 2 phi 2, and your ket chi equals minus I by root 2 phi 1 plus 1 by root 2 phi 2. So we will calculate now trace of ket chi bra chi, so which is equal to the first part multiplied by the second part. So when you multiply the first part and second part, that will give you the answer as we said, minus, you have I squared minus is there, so 1 by root 2. So similarly 1 by root 2 multiplied by 1 by root 2 will give you 1 by 2. So that will give you have 1 by 2 plus 1 by 2, which is equal to 1. Now look at these two results. We have already calculated trace of chi, that is ket chi and bra, ket psi and bra psi, and we have calculated trace of ket chi and bra chi. So one answer was 85, the other one was 1. So out of these two results we can say that psi vector is not normalized, whereas chi vector is normalized, because we have obtained the value as 1. So chi vector is normalized, and so out of these two only chi vectors will act as a projection operator. So this is nothing but a projection operator, completeness. So we'll have the value operator here, they will have the value 1, because this is about inner product, the trace of a matrix, and this is about the completeness. So this is your projection operator. Okay, so that's all students. So thank you so much. We will see in the next class.